started so I don't forget. All right. Hello and welcome, everybody. I know it says week number 8 up here on the main lesson. Don't don't get scared there. It is week 9. Um, this is um, this is a short week. I think you're going to have a really easy time with this week. All we're doing is we're adding polynomial functions together. Super, super easy. I think you'll finish the assessment in about 10 minutes this week. It's really probably one of the easier ones that I've put out there. Usually each week we go through 2 units in our textbook. This week we're only going through 1 unit in our textbook. Can anybody tell me why? Why are we only going through 1 unit this week instead of 2? It is a short week. What does it mean to be a short week? You only have school this week on Monday, Tuesday, and Wednesday. Now some kids are like, well, this is an online school. We can work on the weekends. We can work on Thursday and Friday if you want to. Absolutely, you can. There's no question you can work on Thursday and Friday. I'm going to tell you, though, that all of your teachers in eAchieve will have a meeting all day on Thursday. So if you email on Thursday or if you are doing your work and turn it in, it probably will not get graded or you probably will not get an email back real quick. I try to email back as fast as I can, but on Thursday, we're in a meeting, so there's no way I can. Friday, I'm going to spend some time away from my computer because this weekend I spent a lot of time doing progress reports. So Thursday and Friday, I'm going to turn off and get away from my computer. So let's talk about this week. It's one of the easier weeks, I think. We're going to be talking about monomials and polynomials, and we're going to be talking about adding polynomials together. And I did see this a little bit last week on some students. When you had to tell me what the degree of the function was, there were a few students that were adding things together that cannot be added together. And what do I mean by that? When you have a polynomial function, you can add like terms together. There's no question about that. But you can't add. So for example, if I gave you something like 3x to the 4th plus 2x to the 2nd, last week I had some students rewrite this and say that this was 6x to the 6th, and they said that the highest power was 6. And I'm like, that is not true. Okay? You can only add like terms together. What is a like term? A like term is a term that has the same variable to the same power. These are not like terms. They have the same variable. I agree, they have the same variable. They're not to the same power, though. This is to the 4th power, this is the 2nd power. We cannot add these things together. That is a no-no. So if I had something like 3x squared plus 4x squared, now I have the same variable, I have the same power. I can add these two things together. This would be 7x squared. And you keep the same variable to the same power. Okay? So that is going to be the extent of what we're doing this week. I'm going to be giving you stuff like this. I'll be giving you, let me clear this off so I can put a problem on there. I'm going to give you things as easy as this, like, oops, I got to turn my marker on. 3x to the 4th plus 5x squared minus 2 plus 7x to the 4th minus 2x squared plus 5. That is something that will be on this week's assessment. Okay? What would my answer be there? I'm adding polynomials together. It means I add like terms together. Okay, so what would my answer be for that problem? 3x to the 4th plus 5x squared minus 2 plus 10x to the 4th. I agree. That is one term. Okay, so I would have 10x to the 4th plus a 3x squared plus 3. Now, does anybody know what standard form is? because you have to write your answers in standard form this week. What is standard form? Put them in order. Correct. Highest power to lowest power. This is in standard form because x to the fourth, x to the second, constant. This is called standard form. Needs to be, your answers need to be in standard form this week. So when you add your polynomials together, please rewrite it so it's in standard form. Why do I tell kids to do that? Makes it a whole lot easier for me to correct. I'm only looking out for myself here. Okay, so when it's in standard form, it's a lot easier to correct because everybody should be the same, right? Everybody's answer should be exactly the same. Now, is this correct if I wrote it this way? 3 plus 3x squared plus 10x to the fourth. This is true. I mean, there is no question it's technically true. But if your teacher asks you to put it in standard form, then this really is not true. Would I mark it wrong? I would not. Okay. But I would probably put something about, please write your answers in standard form. No, you don't have to rearrange. When you're doing these problems this week, there's no work to be shown. Okay. You could look at this problem here, and if you can just rewrite this out as 10x to the fourth plus 3x squared plus 3, I'm good with that. There's not a lot of rearranging that you have to do this week. There's no work that you have to show. I will tell you that there are a couple that get a little bit tougher that you might want to write out some work. Okay. But no, this week you don't have to show work. So the degree of a polynomial, and we talked about this last week, the degree of a polynomial is always, if you write your polynomial in standard form, it is always the one with the highest power. That's the degree. So this polynomial would be a third degree polynomial. The leading coefficient would be 5. Now, it was interesting last week because some kids, they added all of the powers together to give me the degree of the polynomial. So some kids would say 3, 4, 5, 6. They'd say that this is a 6th-degree polynomial. It is not. The degree of a polynomial is the highest degree of any one of the terms. So this is a 3rd-degree polynomial. The leading coefficient is 5. Okay? And that's just kind of a review from last week. Now, you will be asked to name one polynomial. The first problem on the assessment this week asks you to name the polynomial. So to name a polynomial, you're going to want to use these names. If it's a constant, just a number, it's called a constant. If it's like x to the first minus 4, anything to the first power is called a linear function. Anything with the highest power of 2 is called a quadratic. Anything with the highest power of 3 is cubic. Anything with the highest power of 4 is quartic. Anything with the highest power of 5 is called quintic. So the first problem on the assessment this week will be something like this. Okay, I'm just going to make up a problem. 2x squared plus 4x to the fourth minus 3x to the fifth plus 5. Okay, and what does it ask? It asks like 4 things. It asks you to write it in standard form. It asks for what the power or what the degree of the polynomial is, and then it asks what the leading coefficient is. Okay, so what is standard form here? Quintic is definitely, so the standard form is negative 3x to the fifth plus 4x to the fourth plus 2x squared plus 5. So that's standard form. So that's the first thing you would do. And then it asks you, what is the degree? Well, the degree is 5. Yep. And what is the leading coefficient? Negative 3. Boom. You're done with that problem. And then it asks you to name it also. Okay, so what would the name of this polynomial function be? And some people already put it in. Be quintic, right? So that's the first problem on the assessment this week. Pretty easy. Okay? All right. So here is the this is a multiple choice question. I think it's on our practice this week. So it's a little tricky, okay? It says, which is a fourth degree trinomial with a leading coefficient of 3? Be careful. A lot of kids get this wrong. Oh, this one wasn't the one that I was thinking of. A fourth degree polynomial with a leading coefficient. Yeah, B is easy. Yeah, no, that was. Oh, wait. All right. It is not B. Okay. Okay. B and C. It can't be B and C. It is only C. Wait. No. It's only D. Why is it only D? Now, it can't be A. Okay. And the reason it can't be A, I'm going to rewrite all of these in standard form. Negative 3x to the fourth plus 13x. No. Negative 3x to the fourth plus x squared plus 13x. Okay. The next one, if I wrote that in standard form, it already is. So it's 3x to the fourth minus 8x to the third minus x squared plus 2. The next one, if I wrote in standard form, well, it already is 3x to the third minus x squared plus 12. And the last one would be 3x to the fourth minus x squared plus x. Okay, why can't A be correct? Why can't A be correct? The leading coefficient is -3, right? It said it's a fourth degree with a leading coefficient of 3. This one has a leading coefficient of -3. Why can't B be correct? B is not a trinomial. What does trinomial mean? Trinomial means it has 3 terms. This one has 4 terms. 1, 2, 3, 4. This is not a trinomial. Yes. So this one is a trinomial. It has 3 terms. The degree is 4. The leading coefficient is 3. So kind of a tricky problem there. Yes. All right. When we're adding, so this week we're going to be adding and subtracting polynomials. Okay. Like terms are terms with the same variable raised to the same power. To simplify an expression, combine like terms by adding the coefficients. This problem right here, what is my answer? Now, when you have more than one variable in a polynomial, you never have to write it in standard form, because standard form assumes that you only have one variable and that variable goes from highest power to lowest power. If you have more than one variable, you don't have to write it in standard form. So this problem has, a P and a Q. So I don't have to write this in standard form. I can just write it any way I want. Okay. So somebody said that the answer is 16p cubed. I'm going to disagree with that. Why? Why am I going to disagree? Because I have 10pq here, I have 2pq here, and I have 6pq here. That's 18pq. Okay, so then I just cross those off. And then I have a 3p minus 5p. It gives me a minus 2p. You can only add like terms together. Okay, like terms means same variables to the same power. Easy peasy, I agree. This one's a little bit tougher. Okay, work it out. Tell me what you get for an answer. But it is a little tougher. Why is it a little tougher? It's got that minus sign. That minus sign really messes some kids up. Okay, doesn't mess me up, but it will mess some kids up. So give it a shot. See what you get there. And then I'm going to take attendance real quick. I'm so glad I figured out that I can just take a snapshot of all your names and then put it in later so I don't have to waste time away here. I'm getting smarter as an old teacher. Old teacher. All right, let me see here. I'm going to put that in there. All right. Attendance taken. Awesome. All right. So you guys are saying that the answer is 8d squared plus 2d minus 9. Oh, I see one that says 8d squared minus 2d minus 9. Ooh, so we do have a couple differences. So let's take a look here. If I had a minus sign here, okay, the first thing I do in a problem that has minuses, I don't like minus signs. So I'm going to change this minus to a plus and make the sign directly behind negative. I'm going to change this minus to a plus and change the sign directly behind to a negative. And then I'm going to change this minus to a plus and change the number directly behind to a negative. Oh, now this parenthesis does not change. So I'm just going to write it out, 14d squared plus negative 8. Plus, and then this negative 1 goes to every single term. So this becomes negative 6d squared plus negative times negative 2. That becomes a 2d plus negative 1 times 1 becomes negative 1. So now I've taken care of the negative sign. So the rest is now just adding like terms together. I've got a 14d squared and a negative 6d squared. That gives me 8d squared. So I'm just going to cross those off. I've got a 2d here, but no other d's, so I'm just going to leave it as 2d. Cross it off. I've got a negative 8 plus a negative 1. Gives me a negative 9. Boom. Done. Negative 7. Where did you get negative? Ansgar, you kind of messed that one up. Do you see where you made your mistake? Okay. And that's the biggest thing is, if you do make a mistake, do you see where you made the mistake? And if not, then you need to ask some questions. Okay. Exactly. And that's why I think coming to these are so important, because we do all the practice problems, and if you guys work them through, you should know what you're doing by the end of it. Yep, I agree with you. All right. So let's go on to this week's practice. Do I have the right code in here? Let's see. Nope, I don't. That's not going to help you guys too much. So I have to get you guys the right view dashboard. I think this is correct. Copy that and throw that into the chat box. Okay. Go into that, see if that's the right one. I think it is. And then I'm going to share my application screen here. So we're seeing the same thing. All right. Are you guys seeing the same thing I am? The x to the third minus 2x plus 3 minus 3x squared plus 4x minus 3? Okay. Now, this week, sometimes the practices, there's not much to do on them. Okay. Does it say algebra on there? Sorry. So sometimes there's not a lot to do. But this week, most of the practice problems I'm going to let you guys work on, because they're very straightforward. Can you do them in your head? Now, I would say some kids would be able to do them in their head, but you're going to make a mistake if you do. Yeah, exactly, Samantha. I'd still write them down, especially this first one with that minus sign in there. That is the one that would, mess me up, that minus sign, because it goes to everything in the parenthesis behind. So try it, see what you get. And then you don't have to write your answer in, just put A, B, C, or D in to the chat box. That way you don't have to, type in the whole polynomial function there. Okay. No, I was going to say, ooh, 2 answers Two people, two different answers. Oh, now they're starting to come in hot and heavy with D for an answer. All right, let's take a look at it. If I was going to do this problem, again, I don't like minus signs, okay? So I'm just going to write this problem over here. I've got x to the third minus 2x plus 3 minus 3x squared plus 4x minus 3. Again, I don't like minus signs, so the first thing I do on a problem like this is I change them. I make that a negative. I'm going to make this a negative. I'm going to make this a negative 3. And then I'm going to multiply through here, so I end up with negative 3x squared minus 4x plus 3. And then over here, I have x to the third plus negative 2x plus 3. Now I can start adding things together. Well, x to the third, nothing to add together. Negative 3x squared, nothing to add there. I've got a negative 2x and a negative 4x, so that gives me negative 6x. I've got a 3 and a 3, which gives me 6. X to the third minus 3x squared minus 6x plus 6. So for those of you that said letter D, I agree 100%. For those of you that did not say D, you misread my own handwriting. All right. Does everybody agree with that answer? Okay. Does anybody have a question on that? Because this is basically what this week is all about. That's it. Adding and subtracting polynomial functions. That is it. Okay, let's go to problem number 2. See what we have there. Oh, another subtraction problem. Okay, so I'm going to let you guys work on this. Put your answer in the chat box as soon as you get it. And then next week when we come back, we get into multiplying polynomials and then dividing polynomials. So it does get a little bit tougher, but this one should be okay. Oh, I've got 4 B's in a row. Okay. Again, if I did this problem, I don't want to harp on this, but I don't like subtraction. Okay, so I've got x to the third minus 2x plus 5 minus 2x to the third minus 3x squared plus 4x minus 3. Whew, that's a long one. I'm going to change the subtraction to addition. I'm going to change this, and I'm going to change this one, and I'm going to change this one. Okay, I just do it because that's the way it makes more sense to me. No, you don't have to do it that way. That's fine. I'm not telling you have to do it this way. I just do it because I know when I was younger, I always made mistakes with the negative signs. So I just change them. I just get rid of them because I don't like them. And the negative times negative, that gets me a positive 3x squared here plus negative 4x plus 3. All right, so now I've got a lot of things, and I've got a lot of things that I can put together, like 1x to the third and negative 2x to the third. That's negative 1x to the third. Okay, see, a lot of guys are okay. So, and then I've got a 3x squared. I don't have anything to add to that, so I'm just going to leave a 3x squared there. Got a negative 2x and a negative 4x. That gives me negative 6x. Get rid of those. And a 5 and a 3, which gives me an 8. Okay, so I'm looking over there, and I see B is correct answer. Very nice for those of you that said B right off the bat. Nice job. All right, let's try number 3 on the practice. Uh-oh, Mr. Tangle, what are you throwing geometry in here for? Okay, so let's read this problem. It says, which polynomial represents the measure in degrees of angle PMQ? Can anybody tell me why I put that in there? Okay, what? This week we're adding polynomials together, right? Do you agree that we're adding polynomials? So what do you think I'm going to have to do here? Yeah, we're going to add both angles together, right? Because we're dealing with adding polynomials this week. So wouldn't you think that I'd have to add this and this together to get the whole angle measure. So I have a squared plus 2a minus 6 plus 3a squared plus 40. That's all it is. If you think about what you're working on, it's like, okay, well, we're working on adding and subtracting polynomials, but this one I'm trying to find the big angle measure, so I just have to add the two smallers together. Okay, so this gives me what, 4a squared. So those a squareds are gone, plus 2a, plus 36. Uh-oh, oh, that's 34. I don't know how to add. So 4a squared plus 2a plus 34, letter C. So when you're dealing with practice problems and you come up across a problem that it looks too hard, you just have to remember, okay, what are we dealing with this week? Well, we're dealing with adding things together or subtracting. Well, I got to guarantee that the practice problem is probably going to be the same. So you have to add it or subtract it. All right. Yeah, exactly. The next one is perimeter. And, perimeter you have to add together. It says, which expression represents the perimeter of the triangle? Well, guess what? Perimeter is you add all the sides together. So if I'm asked to add all the sides together, it's just going to be 3m plus 4 minus m plus 2m minus 1. So now I added all the sides together. Now I just have to do the work. I've got 3m here minus 1m plus 2m, so that's 5m, that's 4m. Okay, I just got rid of all of these. And then 4 minus 1 is positive 3. So 4m plus 3 looks like letter A. Okay, so that's basically, if you run into a word problem, even on an assessment, you have to start thinking about what are we working on this week? And that assessment problem should kind of deal with what we're working on. I try not to put things in there that we're not working on, because that wouldn't be very nice. It is an M, yes. All right. Problem number 5. Add and write the resulting polynomial in descending order of degree. Now this one, you guys should be able to do in your head. I mean, there's really not a lot of work to do here, right? Oh, but we do have two different answers. Somebody said A, a lot of people said D. Oh, wait, D? All right. I think everybody said D now. All right, so we have 8x plus 4 plus negative 11x plus 5. So 8x plus negative 11x, that's negative 3x. And then 4 plus 5 is 9. I'm going to go with letter D on that one. Okay. Number 6. Again, when there's addition, do you need those parentheses in there? Now with subtraction, you absolutely have to have those parentheses because you have to understand that you're subtracting the whole thing off. But with addition, those parentheses don't even need to be in there. So this is another one of those types of problems where you should be able to do, I mean, you guys are Algebra 2 now, right? You should be able to do this in your head. There really isn't a whole lot of work to do here. You should be able to look at this and just add everything together. You're old enough to comprehend this. Now, when we start doing, what is that, long division, then you might not be old enough because that's some tough stuff. Letter D again. A lot of D's for our answers tonight. All right, so in this problem, I'm going to have to write a little bit smaller. 4 plus 9x to the 5th. Oh no, my marker is going crazy. I'm going to try to, if I can get this to be a smaller number here. Okay, so 4 plus 9x to the 5th plus 6x to the 7th plus 8x to the 6th plus 8x to the 6th plus 6x to the 5th plus 7 plus 4x to the 7th. Oof, that's a lot of stuff. I always work with the largest power first. So I've got 6x to the 7th and a 4x to the 7th. That gives me 10x to the 7th. So I got those out of the way. Then I'll go down. It looks like I have an x to the 6th. So I've got 8x to the 6th, 8x to the 6th. So that's plus 16x to the 6th. Got rid of those. I've got a 6x to the 5th and a 9x to the 5th. So that looks like 15x to the 5th. Got rid of those. I've got a 7 and a 4, which gives me 11. So I agree with letter D. You guys see how easy this week is going to be? Just adding and subtracting polynomial functions. That's it. All right, number 7. Which monomial has the highest degree? All right. I guess we kind of skipped over that slide today. Letter B, I disagree with that. What do you mean you disagree with that? Okay, now, when you have a single term, okay, these are all monomials. Why do we call them monomials? Because there's no addition or subtraction. What breaks up a monomial? If you had something like 18a to the 5th plus 14a to the 4th, this is a monomial, this is a monomial. A plus sign or a minus sign breaks up terms. So these are all terms here because there's no plus signs or minus. How do you find the degree of a term? Well, you have to add degrees together. So this is a to the 6th, oops. This is a to the 6th and, oops, I wanted to change this. This is a to the 6th and b to the 1st, so this is a 7th degree monomial. This is to the 4th, this is an 8th degree monomial. 2, 2, 2, this is a 6th degree monomial. Because you have to take all of the terms together to figure out what the highest degree is. If not, and most of the time, Joseph, that is correct, because most of the times we're just dealing with things like this. We're dealing with like 5x to the 4th plus 5x squared plus 3x to the 2nd. These are all terms. So the highest degree would be here. But if I put a y here, then this is no longer a 4th degree monomial. Then I have to add these two together because this is a 4th and a 1. So this would be a 5th degree monomial. So if there's more than one variable in there, you got to count those variable, or you have to count all of their degrees together. Okay? That is how you find the degree. And usually we don't deal with degrees of polynomials with more than one variable. It's always just an x or something like that. So that's it. All right, so let's try. So the answer should have been letter C, right, for this one? Because then 8th, 4 plus 4 is 8. All right, so let's try number 8. I don't know what the problem is. Which monomial has the highest degree? Okay, so kind of review what we did there. So letter A, what is the degree of letter A? 5. Okay, what is the degree of letter B? 9. I agree. Very good. What is the power of letter C? 10. You guys have got it. And letter D? 7. Very good. A lot of people wouldn't say 7 for this one. However, every variable has a power. This one, if it's not written in, it's a 1. So we've got 2 plus 1 plus 2 plus 2, which is 7. So that would be a 7th degree polynomial or monomial. So the answer to this one, which monomial has the highest degree, it should be letter C, right? Because that was 10. Yeah. But letter D was a little tricky there because they didn't put a power there. But you have to remember, if there's not a power on there, there is a 1 there. You have to know that. All right. Let's go on to problem. I don't even remember what problem we're on right now. All right. Uh-oh. Does this look familiar to some of you? No. We did this one already, didn't we? We did indeed. I have a few extra students that came into class, so I want to make sure I keep good attendance here. So nobody is marked not here. Okay. Even though it doesn't really matter, but I do like to keep attendance. Okay. So we did this problem previously. It asks, what fourth degree trinomial leading coefficient of 5, and we rewrote each of them in standard form because I think that's the easiest way of doing the problem is write in standard form. So if I rewrote this one, it would be negative 3x to the fourth plus x squared plus 13x. This one is already in standard form, so it's 3x to the fourth minus 8x to the third minus x plus 2. This one's in standard form already, 3x to the third minus x squared plus 12. And this one I have to rewrite 3x to the fourth minus x squared plus x. So it asks, which is a fourth degree trinomial with a leading coefficient of 3? Well, in this problem, the leading coefficient is negative 3, so that is incorrect. B, it has a leading coefficient of 3 and a degree of 4. However, it's not a trinomial. A trinomial has 3 terms. This has 4 terms, not a trinomial. So this one has a leading coefficient of 3, power of 4, and it has 3 terms, which is a trinomial. So the answer was D. Okay. All right. And I think we should only have like one or two more problems to go here. Which of the following is a fourth degree trinomial with no quadratic term and a leading coefficient of 3? So I'm going to let you guys do this one. Okay, so it's a little bit trickier. What does it mean by no quadratic term? What does that mean? Yeah, there's no x squared in the problem. That is absolutely correct. Right. Yep. So you guys are saying the answer is C? Okay, so I'm going to rewrite letter C in standard form. So that would be 3x to the fourth plus 6x to the third minus x. Okay, so now, which of the following is a fourth degree? This is a fourth degree polynomial. Trinomial with no quadratic term. There's no x squared in here, so that's okay. And a leading coefficient. Oh, you guys are absolutely correct. Letter C is the correct answer for that one. Why can't there be an x squared? Because it says, if you read the directions, it says which of the following is a fourth degree trinomial. So it means it has 3 terms with no quadratic term. Quadratic means x squared. Anytime you see quadratic, you should be thinking, oh, an x squared term. There is no x squared term. So you can't, so like letter D can't be right because there's an x squared term in there. You got to cross that one off. Okay, so that's, a lot of terminology in that problem. You have to know what a trinomial is. You have to know that it has 3 terms. Quadratic, you have to know that that's an x squared. Leading coefficient of 3. Yeah, so there was a lot of stuff going on in that problem. Okay. All right. Was that the last problem on the practice this week? That was the last problem on the. Now, you guys are going to, as I said, I think you're going to have an easy time with the assessment this week. It is rather straightforward. It's just adding and subtracting. Now, let me put a problem on the board that might cause some problems. Okay. Let me see here. I wanted to go. No, that's not what I wanted to do. Cancel. Okay. Nope, I didn't want to do that either. Mr. Shanklin doesn't know what he's doing. It's not a first time. All right. Let's say I gave you a problem like this. Okay, and this is going to be the last problem for today. So let's say I gave you something like this: negative 2 x squared plus 5x to the third minus 3 minus 7x plus 4 plus -3, 2 minus x squared. All right. That would be the toughest problem that I could give you. Okay? It's got a lot of stuff in there. It's got minus, it's got addition, it's got negative signs, it's got positive signs. Put it together. Does somebody want to work it out on the board for us? Okay, Samantha, you're up. Do you know how to write on the board? So why don't you do, yep, there you go. So work it out and we'll see. And everybody else, do it at your desk. You know, this is work. This is, as I said, if you want to go in and look at the assessment for this week, you won't see anything harder than this. If you got that, you got message ting. Yeah, I know somebody's tinging me on my phone here. And there's a lot of tings there, so it must be important. Probably not. Okay, I'm just looking here, negative 2x squared, minus 10x to the third, plus 6, everything looks great so far. Minus 14x, minus 28, I love it. Very nice. I love the color too. And this is, as I said, has anybody looked at the assessment yet for this week? Yes, my phone is tinging. I really should turn it down, shouldn't I? Sorry about that, guys. Just my son. He put an offer in on a house, and he learned this morning that he was outbid, which does happen a lot. Negative 6 plus 3x squared. I love it. Samantha, awesome. So good. Very nice. And now just adding like terms together. Man, Samantha, we should have you teach. Your handwriting is way better than mine. This is not even funny. Do you have a tablet that you're writing on? Because if you're using your mouse and doing this, this is going to be in. That's your mouse? Holy cow. Your writing is way better than mine, and I have a tablet. That's, man, I need to retire. Samantha, you can take over for me here. Oh, man. I love your work. It's negative 28. Yeah, it's some awesome work you're doing. Very nice. You won't see anything harder than this on the assessment. That's it. I mean, that is it for this week. So that's it for this week. Remember, it's only a 3-day week. We only have Monday, Tuesday, and Wednesday. So if you're emailing your teachers on Thursday and Fridays, trust me, you probably won't get a message back because we have a meeting, a full day meeting on Thursday, and Friday most of your teachers are probably going to relax because we had to do progress reports this week. So yeah. All right, you guys have a great week. Don't scare the trick-or-treaters too much. Like, that's okay. They're just the same, Ansgar. They're just the same as regular parentheses. You can look at them as normal parentheses. There's nothing that you would do any different if you had square ones or rounded ones. All right, you guys have a great week. Hopefully it'll warm up and the rain will go away.